Introduce to you from MasterCut tool, Mr. Michael Shaluly. Good morning, Michael.
Good morning, everyone. Thank you for hosting us, and thank you for hosting this meeting. It's great to see everyone.
And thank you so much for joining us. We've talked to the students a little bit and explained about Manufacturing Month and a little bit about why manufacturing is so important to our region. But what we'd love to hear is your take on why manufacturing is important to the region, a little bit about you and what you do at MasterCut Tool, and about your company. Most of the students should have watched your video, so they do have an idea of what you do, but it's always wonderful to hear it directly from our manufacturer.
Great. Well, thank you, Beth. And thank you to all the students who are participating. We really appreciate you being here. And not only that, we need you here. Manufacturing is so important for society in general. Everything that you're working with right now had to be manufactured. You're sitting at a desk, you're in a chair, you have a pencil or a pen in your hand, you have a computer that you're looking at. Manufacturing is at the root of all of those things. And we need to have a strong manufacturing base in order for things to continuously progress, for us to learn more, for the world to find ways to do things better. I know manufacturing has had a kind of a bad reputation. There is a large environmental movement in the world today. All of us want to take care of this world that surrounds us. Manufacturing is at the root of that. Technology is pushing us forward, finding ways to use less energy, to do things more efficiently, to make sure that this world remains a cleaner place, even while we take advantage of the wonderful technologies that continue to show up. So you'll be at the very front of that, the front of the technological advances, ways that we can improve life for one another, and ways that we can improve life for those generations to come after us. So we, all of us here on Manufacturing Day, we want you to see the importance of manufacturing. And Beth, you said you expressed it very well as to how manufacturing can also be a wonderful career. So when you come into a manufacturing plant, which would include ours, you see a nice clean factory floor in most cases. You see the most advanced technology, and you become a part of that. Technology today is always advancing and always changing. It's not what it was when I first started. So I started in this industry in 1979, and there were machines there that were probably 30, 40, 50 years old. The technology was slowly changing. But within a decade, computers kind of started taking over. Technology just was advancing quickly. So if you were to come into our factory today, I can guarantee you that within a year, much of what you're seeing will already have changed. And not only that, you'll be a part of that change. At MasterCut, we have a very specific training program that takes this advancing technology into account. So you become part of continuous training. And that continuous training never ends. It never ends for me. It never ends for Diane or Shane or anyone else who is here at MasterCut. And I think most manufacturing firms that are competitive in the world today will have programs like that. So a little bit more about me. I started again in 1979 in this industry, and it stuck with me and I stuck with it. I do remember thinking, I'll do this until I can get a real job. But once I started making the product, and we make, carbide cutting tools, and they're really cool looking things, but they also have a very profound purpose in industry. Once I started making these and seeing what went into it and how they were used, I was hooked. And I still love it to this day. learning about the different geometries that go into making a cutting tool work on aluminum rather than titanium. The marketing side, making sure that the world knows what we're doing. The technology behind it, how we use computer programming and simulations to make sure that we're as efficient as possible. So I stuck with it, and here I am almost 40 years later. I think we'll have our 40th anniversary in 2 years. So I know I don't look that old. I know that's what you're saying out there, but yes, we've been at it for some time. So did I miss anything? A little bit about me, the company, you know, obviously it's 38 years old. We probably have a couple hundred machines total in the factory. Now that would include things such as our printing machines. We print our own catalogs, and we do a wonderful job. Shane here in the marketing department takes care of that. We print specialty things for some customers. Maybe it'll have their name on it and our names. Here's one that we printed at 35 years. It was like an anniversary publication. But we also have a lot of machinery, multi-axis robotics, machines that simulate a product before we make it. And we make everything from carbide burrs like this one to gigantic, you gotta be strong to lift this thing. It's a tungsten carbide 6-flute end mill. And that's about as big as we would make a carbide tool. This thing probably weighs about 10 pounds by itself. And tungsten carbide is a very hard material. It requires diamond to cut it. So all of our machines have diamond wheel packs that are grinding these different geometries into these carbide cutting tools for industry. And the tools are used in everything from dental manufacturing for making dentures, all the way up to aerospace. We have a carbide tool on Mars that's drilling into the Mars surface on one of the rovers there. That's about it.
Wonderful. Thank you so much for that intro and additional information. We do have a question that came in from Dunedin High School. They're incredibly glad to meet you, they'd like to say. And they have a question about what software you use for modeling or receipt of part and tool specs.
Okay. So for manufacturing the carbide cutting tools, there's specific modeling software that we use from the manufacturers of the multi-axis CNC machines. So one machine is an Anka machine. It comes from Australia. They're 5 or 6 axis machines, and they have their own tool simulation software. It's the same for Rollomatic, a company out of Switzerland. They have what they call Virtual Pro, and that allows us to simulate the manufacturing of the carbide cutting tool before we even get to the machine. The simulations are very specific. You can do a scan out where you can see the entire machine and the grinding wheel coming into the tool. You can get very close and look at all the dimensions that you're making. We use it to not only simulate the tool, but to make sure that the setup is correct and that there's not going to be a crash on the machine. Walter is another machine that we use. And again, they have their tool studio, they call it, which is their simulation software. They're very advanced. We get cycle times so we can quote the customer, and the cycle times are very accurate from the simulation. So it helps us not only to make the tool, but to quote it to the customer as well. Then we also use SolidWorks. So we have to do some engineering within MasterCut, whether we're modifying a machine or we're building a machine or even making shelving and that sort of thing. We use SolidWorks for that. And all of our software is integrated. So from AutoCAD, we can, we have a software that takes an Excel file that has all the dimensions in columns and rows. And you can take one dimension in that Excel file, change it, and then convert that back to the AutoCAD file so that you don't have to redo a print. The print is already made. It's just that dimension would change. We can also take a picture from our scanning machine. It's basically a quality control camera system we can take a DXF file from that, and we can take that and put that into the simulation software and automatically create a simulation. We can then take that simulation and dump that into AutoCAD so we get our 2D print. So it makes life much easier. It has reduced the amount of time it takes for us to create prints. When we do a special tool, we have to create a print. The customer has to sign off on the print before we can start production. So all of the softwares work together in that manner.
Thank you very much. And Eastlake High School has a question. Does your company host internships for high school students, and how young do you hire?
I think that you have to be at least 17, is it? I think you have to be 17 to work on some of the machines. So some of the office jobs, and we do have internships to answer that question. And we do work with the high schools, and we'd love to have more interns from high schools. And I think in the office, you can be as young as 16 to work in the office. There are laws around that. You can only work so many hours and that sort of thing. So we always make sure that those laws are followed, and your parents and yourself would have to do that as well. But in the manufacturing floor, I'm pretty certain it has to be 17. I don't work in the HR department anymore, but we would really love to have interns from the high schools working, even if it's in the AutoCAD department, the quality control department. You may not be running a machine initially, but you'll be learning about the operation, you'll be learning about the cutting tools, and you'll be helping to create processes, procedures, and prints around what we do on the manufacturing floor. So yes, we do have programs. We are working with some of the high schools now, and we would love to see more interns.
Wonderful. And Michael, if they are interested in an internship or interested in a job opportunity, how would they apply with your company?
So you can go online and you can apply there, or send it. I think we have an email where you would send the email, and if you have a resume, to hr@mastercuttool.com. HR will respond to you and ask you to come in. They'll schedule a date for you to come in so we can meet you, talk to you, and find the best area for you to begin.
Okay, wonderful. And if we could get that information in the chat, if Daniele or Teresa, you could put that in the chat, or Michael, if any of your folks would like to put that in the chat so that they can
Yes.
take that down and keep that information for
Okay.
future.
Yes.
Thank you
So
so much.
my page, HR@MasterCut.
HR@MasterCutTool, all one word, .com.
Perfect. Thank you.
And Michael, we have another question. How long does it take to make most of the bits that you produce?
We have cycle times for everything that we make. Obviously, if you're making this baby, it's going to take a lot more time than if you're making this little baby here, this tiny tool for making dentures. So the longest cycle time generally is around 25 minutes for one tool. The gigantic one I have here takes about an hour and a half. But you know, like a 1/2-inch diameter 4-flute end mill, square end mill, that's one of the more common end milling products that we make. That runs, depending on the machine, that runs in around 5 to 6 minutes. Some of the carbide burrs, similar kind of cycle time. Some of the smaller burrs might be less than a minute. So we probably produce around 8,000 to 10,000 pieces per day in the factory. So the cycle times vary. And if we're running lots of small parts, that number will go up. If we're running lots of bigger parts, that number could go down.
And what is the smallest part that you make? Have you mentioned the smallest? And what makes that more challenging, or is it less challenging than making a larger part?
The smaller parts are definitely the most challenging. We make tools down to 0.003 in diameter. That's about the diameter of a single hair on your head. So to make something like that, everything has to be perfect. We use diamond wheels to grind into that tool. The diamond wheel has to be absolutely perfect. The angle that that diamond wheel comes into that 0.003 diameter piece that you're grinding into, everything, all the contact points have to be perfect. So it is a big challenge to make small tools like that. We have a pretty unique system of wheel dressing. We dress our diamond wheels on CNC machines also. And the CNC machines have a catalog of every single diamond wheel pack that we make, so that we know what angles are there. That information about that wheel pack is saved. So an operator will take the wheel pack, put it into the CNC wheel dressing machine, and basically call up that cataloged part number for that wheel pack, and then let the machine do the rest. And it will dress that wheel very, very intricately. And this is so important when you get to the tiny tools. It's important on all of them, actually, to have the proper wheel dressing, the proper angles, and that sort of thing. But when you get down to the tiny stuff, it becomes even more so. Even temperature control. So to make the small tools, we have to have the oil, the coolant oil that we use. It has to be temperature controlled within 0.5 degree. The cabin inside where the tool is being ground, that's temperature controlled with an air conditioning system. So yes, it's quite a challenge to make the tiny ones.
Thank you for that. Do we have some more questions from the students?
So just one thing for the students, anything that you might be studying is important in most manufacturing environments. We make carbide cutting tools, but within that realm, we use robotics. We have needs for mechatronics. We have needs for computer programming and computer science. Anything that you can think of that you might be taking that is technology related or manufacturing related would be used here. So we encourage you to keep that in mind. We have needs for AutoCAD, and so whatever you're studying, there would probably be an application here. And there is another type of application, one that you can fill out, that's waiting for you here as well. We'd love to have you.
And do you currently have some job openings?
We do. We probably need about 10 operators for the machines. The operators will learn how to program, run, and quality control check products coming off of the most advanced CNC equipment on the planet, designed for the work that the product that we make. They're mostly 6-axis machines. They have wheel exchangers. They have internal measurement systems. So it's a journey, of course, to train and learn. But we do have a wonderful, and it's called our Master Path. It's a wonderful training program where you go through various belts, the white, the green, the yellow, the black belt. You become an expert at what you do, and you have many opportunities to move through different levels of the manufacturing process.
Thank you. We have another question that came in from Eastlake. They know that many Pinellas County students aren't learning SolidWorks, but other CAD programs, Inventor, Fusion 360, etc. When looking to hire, is knowing SolidWorks important, or would general knowledge of CAD software work?
General knowledge of CAD software will definitely work. We probably use other softwares that, because we have so many different areas within our factory, we're probably using some of those other simulation softwares now. So as an example, I don't go out to our maintenance area where they run the milling machine, and they'll run the milling machine to test our tools. They'll also run the milling machine to manufacture a component for a grinding machine and that sort of thing. And they do use software. I'm surprised. I go out there and they've created a software using Microsoft Teams or what have you. They've created a maintenance software. There's a possibility that some of the modeling softwares you've mentioned are actually already in use. So any knowledge of any CAD program would be useful.
Okay, that's great to know. And Dunedin High School has a question. The students are curious to know what the cost of the most expensive diamond cutting tool is.
So a diamond wheel is what we use to cut carbide, to grind the carbide. So the most expensive diamond wheel probably is around $2,000. So sometimes I see our operators walking around with a wheel pack in their hand, and I cringe because there's a lot of money in their hand. And when I say a wheel pack, there could be 3-4 wheels in that one pack, and each wheel has an operation that it does when the tool is being ground. So diamond wheels are quite expensive, up to about $2,000. Now, when you talk about the tools themselves, a tool like this is a 1/2-inch router for routing furniture manufacturing. There are times, and this tool probably would sell from distribution maybe around $70. We don't get to sell it for that much, but when it gets to the end user, it's that much. It's just like when you go to Home Depot, you'll see something on the shelf that's $5. It probably we manufactured it for 20 cents to 50 cents. But by the time it gets to the shelf, it's $5. So anyway, this might be, let's say this is a $20 tool. There are times when the customer might want a diamond coating on this. The diamond coating is really hard, and it becomes more of an abrasive tool. So you use diamond coating when you have really harsh abrasive style material to cut. And you still need the flutes like this so that the material can evacuate, but you want a diamond coating on there. To diamond coat this is probably $100, just the diamond coating. So it's far more expensive than the tool itself. So some of the most expensive tools that we make from carbide could be over $1,000 simply because they're diamond coated after we do our process.
What determines what material you use?
We use only tungsten carbide. We have a few grades. One grade is a 3% cobalt content. The less cobalt content that you have in the carbide substrate, the harder it is. Tungsten is a very hard material. The cobalt is the binder. So if you have less cobalt, you have more of that hard tungsten material, and it becomes brittle, more brittle and harder to work with. But generally speaking, we use a 10% cobalt grade, which is also, it's very hard. It's about a 92 Rockwell C. Now, when we get questions from customers, they might tell us something like, look, I'm milling aluminum and it has this much of a silicon content in it. Then we can make a decision on what tool is best for them to use from us. So we have aluminum cutting tools. If it's a higher silica content, we might want to put a different type of coating on that tool to help with that. So our material, our raw material, there's only about 5 or 6 different substrates that we might use, with 90% of it being a 10% cobalt content grade. But out in the world that we service, there's lots of applications, and we have to be aware of that when we sell the product.
Good to know. Thank you. Do we have any more questions from any of the classes?
Great questions, by the way.
Yeah, they are asking wonderful questions. Anything else you'd like to know?
Well, if no one has anything to say, I would like invite on behalf of MasterCut everyone to the 5K, which will be Saturday, October 18th. Is it, Mike?
It's the 21st.
21st, sorry.
Yes. And we really look forward to everyone coming. We're already over 200 participants, 220. So we'd love to have you. It's all about manufacturing. It'll be a great morning. We start at sunrise. So yes, you have to get up early, but it's a wonderful time of year, and we watch the sun rise, and then we just take off. And we have a great time. Many people walk. You don't have to jog it. So yes, thank you, Daniele, for bringing that up. We'd love to have everyone.
And tell us the theme this year, Michael.
The theme is it's called Ghouls for Tools. And so it's a Halloween theme. You can come in costume, and we'd like to see some costumes out there. Yeah, and there's some prizes. Maybe Diane can say a word or two.
We'd love that. We'd love to hear more about it.
$100 for the best costume, by the way.
How many?
$100 for the best.
$100. That sounds
Person that wins
wonderful.
best costume.
Okay, okay. So we have a challenge now, and if we can also put in the chat the link to where they can register for that 5K run coming up in a couple weeks. Diane, would you like to say any more?
No, she's okay.
Okay.
I think we covered it.
But we'll put the information in the chat, and if you're interested, there's a couple ways to win prizes, either by putting on a costume or by running in the race. So it is a lot of fun, and we'll be out there that morning as well.
And we'll have customers from all over the world. So part of this, I think, is from Japan. So we'll have a group of customers actually competing from Japan.
Oh, wow.
We'll have some vendors there from across the country. It'll be great.
And what are you raising money for? Can you let the students know?
Students, we're raising money for you.
Exactly. Scholarships, so you will be getting one of those.
That's right. All of the money raised goes towards scholarships. So BAMA is a recipient, and Skills is a recipient, SME is a recipient, and who am I missing? Nuts, Bolts, and Thingamajigs. They're recipients, and they find students who are either going to vocational centers or universities working towards a manufacturing degree of some kind, and they get scholarships for that. And we've raised around $170,000 total. So that's quite a few scholarships that have made their way out there. So students, it's for you. And that's why we'd really love to have you out there.
And it's a fun time. So
Yes, it is.
well, we'll be wrapping up, and then we're moving on to another one of our local manufacturers. But Michael, is there anything you'd like to say in closing to the students?
Well, stay at it. We need you, and we need you to continuously improve the things that we're going to bequeath to you. Manufacturing is such an important and integral part of the world that we live in, and we need you to be a part of that. We need great minds, and I see some of you out there right now through the camera. We need you to be devoted to making things better in this world. That's what we've all tried to do, and that's what we continuously try to do. It's all about helping one another and doing our best to make the world a better place. And manufacturing is really at the root of that. So we thank you all for being with us today. We thank you for the work that you're doing, learning about manufacturing. And we hope to see you, whether it be at the run or here at MasterCut or in some other fashion out in the manufacturing world. Thank you all.
Well, thank you, Michael. Everyone say thanks to Michael. Have a great Friday, and we will see you at the run. We will be there.
Thank you, Mike.
Thank you again
Thank
for joining
you.
us.
Bye.
Bye-bye.